In this lesson, we are going to talk about simple random sampling. So, um, previously we talked about an observational study versus a designed experiment. With an observational study, one of the ways that you can do that is by giving a survey. And in order to give a survey, we need to identify the population that we are targeting. So, who do we want to know things about? So, who are we going to give this survey to? So, the process we do that by is random sampling. It's the process of using chance to select individuals from a population to be included in the sample. So, there's a little blurb from your text there. For the results of a survey to be reliable, the characteristics of the individuals in the sample must be representative of the characteristics of the individuals in the population. The key to obtaining a sample representative of a population is to let chance or randomness play a role in dictating which individuals are in the sample rather than convenience. If convenience is used to obtain a sample, the results of the survey are meaningless. So, say for example, I want to survey. I want to know something specific about all the math students at our school. Well, there's more math teachers than just myself. So, convenience would be me just surveying my math students. Since I see them every day, I could easily give them a survey and make sure they get it filled out and turned back in. Whereas, really, that would only be representing my math students, not all math students in the school. So that would be convenience, and the results that I would get would not apply to the entire population because there's younger math students in the elementary, other students from different classes that I've never had before. So we're just not including everyone that would represent the entire population. So if convenience is used to obtain a sample, the results of the survey are meaningless, and simple random sampling is the most basic sample survey. Also, the number of individuals in the sample is always less than the number of individuals in the population. So your population is all the individuals you're trying to study. The sample is a smaller group of the population that could represent the entire population. All right. Some notation here is that a sample of size n, so samples are given by size lowercase n, from a population of size capital N, so population, its size is represented with a capital N, is obtained through simple random sampling if every possible sample of size lowercase n has an equally likely chance of occurring. The sample is then called a simple random sample, so this should say sample. Okay, so when we get to actually performing some mathematical operations, we might have some formulas that use a lowercase n versus a capital N. Lowercase n is representing the sample size, capital N is representing the population size. So some steps here for obtaining a simple random sample. First, we're going to obtain a frame that lists all individuals in the population of interest. We will number the individuals in the frame from 1 to capital N. And then we will use a random number table, a graphing calculator, or statistics software to randomly generate lowercase n numbers where lowercase n is the desired sample size. I mentioned the word frame. What a frame is a list of all the individuals within the population. So it could be all of the high school students taking a math class. I would list all of those students on a sheet, and then I can go from there, and we'll talk about what we do next. Two different things that can happen is you can have a sample without replacement. Which is where an individual who is selected is removed from the population and cannot be chosen again. So once someone is chosen once, they do not go back in to be chosen again. I feel like we use this most often, especially with surveys, because once you survey one person, you're not going to want to survey that person again because you're just going to get probably the same survey answers from them. In a sample with replacement, a selected individual is placed back into the population and could be chosen a second time. So I don't know, I guess maybe think if you entered a raffle of some sort, maybe they were raffling off 5 items. Well, your name could potentially be drawn, and then if we were doing it with replacement, it could be put back in so you had a chance to win something again. If it was left out, that would be without replacement, meaning you would not have the chance to win something again. So, example number 1 here. The House of Representatives has 435 members. Explain how to conduct a simple random sample of 5 members to attend a presidential luncheon. Well, I already have it typed out for us there. What we would do is list all 435 members and then assign each member a number between 1 and 435. Then we will use a random number table or technology to choose 5 random numbers between 1 and 435. So that's what we're going to do. So for part B, we're going to find a simple random sample of 5 members using the random number table below. Start in row 3, column 6, and proceed downward. So where we are told to start, this is randomly chosen or randomly given to us. All right. So if I am looking here, row 3 is this row here. Column 6 would be this first of the set here. So our starting point is this 9. Now, our range of numbers goes up to 435, which is a 3-digit number. So all of our number selections, we're going to go 3 across. So what I'm seeing here is I'm starting with the number 920. 920 is not in our range of numbers 1 to 435. So that doesn't do us any good. So we just kind of cancel that one out and move on to the next one. 095 is the number 95. 95 is in our range of numbers. So whoever member number 5 was, they are selected to go to the luncheon. My next number would be 539. That's not in my range of numbers. 971, not in my range of numbers. When I go to my next set of numbers, I go to the next column we haven't used yet and go to the top. So I would go 481 because we need 3 digits max. So 481, not in our range. 982, not in our range. 677, not in our range. 593, not in our range. 386 is, so person 386 will be chosen. Next number is 133, so person 133 is chosen. If we go to our next spot, 456, not in our range. 632, not in our range. 420 is. 480 is not. 534 is not. 200 is. So there we have chosen 5 numbers. Those 5 numbers are representing a person, one of the members of the House of Representatives. So those members are the ones chosen to go to the presidential luncheon. All right, so doing that's not terrible when we're trying to grab a small number of members or a small sample. But if you get to a bigger sample, I feel like you're going to run into issues doing that, and that's going to take some time. So our other option is to use technology, and in our case, we're going to use StatCrunch. So to get to StatCrunch, you guys are going to go through Canvas, open up My Math Lab, and then on the left-hand side will be StatCrunch. Click on that. You will then click on the link that says Visit StatCrunch website. And then from there, you will have to open up StatCrunch. And this is what it should show you. So here's StatCrunch. We're going to be working with a lot of different things in here. So to get a simple random sample, we are going to go to Data. We're going to go to Simulate. And then we're going to go to Discrete Uniform. Okay, so we have this little box that pops up. We got Simulate Discrete Uniform. The rows, we are going to choose 5 because we are choosing 5 members from our representatives. We'll just put it in one single column and go down the column. Our parameters, the smallest number we can have is 1, and the largest would be 435. So that pertains to your range of numbers. And then if we look down at the seeding, we can either use dynamic seed or use fixed seed. And I'm going to do both and talk about the difference here. So first, if we just use dynamic seed and I compute, I get the numbers 350, 153, 189, 222, and 30. So those would be the people that I choose to go. I'm going to do the same thing here. I'm going to put it in this second column. So Data, Simulate, Discrete Uniform. I'm still choosing 5 people, one column. Minimum is 1, maximum is 435. I'm now going to choose used fixed seed, and I'm going to choose the number 24. Let's make sure. Yep. Okay, so I'm going fixed seed, the number 24. That seed can be whatever seed you are given. Okay, so we don't have to use 24 every time. I'm just giving you the number 24, and we hit compute. We get the numbers 107, 199, 110, 242, and 165. Now, what that does is when we're in the same program and we are using the same seed, we're going to get the same random sample. So we're going to be using this in your homework. So to ensure that we're all using consistent numbers throughout the homework, just to get things right and make sure we're doing it correctly, we're going to use a seed that gives us all the same random sample. So if I go back to our notes here, I'll write down the steps for us. We hit Data, and then Simulate, and then we did Discrete Uniform. Then that's when the box popped up. We chose 5 for the number of rows because that's how many members we were selecting. For columns, we just did 1. And our min and our max was our range of values to choose from. Okay, so when you do a dynamic, when you choose a dynamic seed, that means you get a true random sample. And just to write down what I got, let's see, 350, 153, 189, 222, 30. So that's what I would have chosen with that. With using seed equals 24, we got the list of numbers 109, 199, 110, 242, and 165. All right, also notice we didn't run into any repeats there. We will in the next example, so I will show you what we can do to help us out with that. So, example 2 here, the table below lists the 45 presidents of the United States. So you got 1 through 45 there with the names. Explain how to conduct a simple random sample of 8 presidents. Well, we're going to use the numbers for each president in the table above. And we want to use a random number table or technology to choose 8 random numbers between 1 and 45. So find a simple random sample of 8 presidents using the random number table below. Start in row 2, column 4, and proceed downward. So this time our number only goes up to 45, so we're only going up to a 2-digit number. So if we are starting in row 2, column 4, so row 2, column 4, our first 2-digit number is 46, which is not in our range. Next would be 48, not in our range. 77 is not. 46 is not. The number 3 is. So number 3, that refers to Jefferson, would be chosen. And then we go up to the next 2-digit number would be 11. Number 11 would be Polk. Then we have the number 64 not in our range, 92 not in our range. The number 9, which would be W.H. Harrison. $53 is not in our range, 97 is not in our range. Next would be 44, which is, that would be Obama. $59's not. 6 is. 6 refers to J.Q. Adams. Um, 55 not. 93 is not. 11 is, however, we already chose number 11. So we're just gonna, it didn't tell us specifically whether to do with or without replacement. We're gonna assume without replacement. We're not going to choose him again. So we just treat number 11 as if it's not in our domain anymore because we already used it. So we'll skip over 11. Our next 2-digit number then would be 81. Don't have it. 82, don't have it. 77, don't have it. 93, nope. 86, nope. 33, yes. that refers to Truman. So we have 6, we need 2 more. Next would be 45, which we have, that is Trump. '63 we don't have. 42 we do have, and we have not used, that is Clinton. So that would be our last one. So there would be the 8 randomly chosen presidents using that number table, random number table. So let's go ahead and do that using StatCrunch. So I'm just going to go to my next column. I'm going data, simulate, discrete uniform. I'm choosing 8, so I'm going to do 8 rows, 1 column. My numbers range from 1 to 45. Let's go ahead and use fixed seed and do 24 again. Oops. There we go. All right. If I compute that, notice I got 12, 21. Oh, I have 12 again, and we weren't repeating. 26, 18, 26 again, and we weren't repeating. 31, 29. So really, I only have 6 options there. And I wanted 8. So to kind of help avoid that, it might be helpful if when we do data, simulate, discrete uniform, maybe choose more rows than what we're truly looking for. So if there's repeats, we can skip them and still have other options. So it really doesn't matter. I'm just going to go 20 with 1 column. Numbers from 1 to 45. And then I'll go ahead and use the fixed seed. And we'll go 24. Compute. So now it gives me a list of more numbers. So if I have to skip one because we were doing without replacement, then I can, and I have options to choose from. So here we're going to have the numbers 12, 21, 26, 18, 31, 29, 33, and 44. So I just followed the list down, but did not do any doubles there. So with seed 24, we have 12, 21, 26, 18, 31, 29, 33, and 44. Okay, so in your homework, it might tell you to use a specific seed. Make sure you use that seed so you're getting the correct sample that they are looking for.